Hello friends, today we are going to apply some special boundary conditions. Like sometimes it may so happen that you are applying load or pressure on a specific location or a single point or a specific area, right? So how to apply this one? We show using SolidWorks, right? Maybe you are starting with this one with a simple rectangular plate. What we'll do is we'll draw a rectangular plate and left side of that one we'll fix it, and at specific locations we will apply point load or pressure on a specific area we have to apply. Starting from new part, select the plane, top plane, normal to sketch rectangular part, select a rectangular part. So we are drawing a rectangular part without any dimension. Next, smart dimension to be provided. Let's provide length equal to 500 mm and width equal to 100 mm. Drawing is complete. So exit from the sketch and select the sketch, features, extrude body brace, and we can provide thickness through the mid plane. Extrude thickness of 20 mm we are providing. Okay, model is complete. Next we will go for analysis. We are starting our simulation. New study, green check. We are starting a new study. First of all, we have to apply a material properties to be done. So select the part, apply edit material. We can apply a steel, A36 steel, which is having modulus of elasticity 2E5 and Poisson's ratio 0.26. Apply, close. Material properties provided. Next part is you have to fix the left side. Fixture, fix geometry. Select the left side. Left side is selected. Okay. Displacement of left side is 0. That means it is fixed. Next part we have to apply pressure or force. First case we are applying a force of some specific value at this point, and point load we are applying here, right? So to create a point load, we have to create a simple geometry. It can be done by using a straight line, by two intersection points, by providing a circular area also it can be done. We'll show all these things one by one. Let's start some sketches. Sketch, select the plane. Let's draw some straight lines. First we are drawing a straight line from here. First straight line is done. Another straight line we will draw. Maybe this is another straight line. Another rectangular area we will draw. Done. And one circular area will draw also. Done. These three things we have drawn, right? Okay. And a single line also you can draw. No, this is enough. Okay. Drawing is complete. Exit from the sketch. What we are doing? We are doing analysis. So we have to start from analysis. Simulation, analysis. External load to be applied. We want to apply a force on a specific point. Point load we want to apply. So force is there. Now we want to apply a point load at this point. As extreme right side single point. But point is not generated. That to be generated. How to generate that point? For generating, we have to start from reference geometry. Right? So exit from here. Features, reference geometry. So point is there. Now we have to select a point. For selecting a point, different options are available. The options are, first easiest option is this center of face. One specific face will be there. At the middle of this face, point will be created or generated. If you select this one, that means you have to select a specific face. You select this one, at the middle of this face this point is generated. Okay, this is point number 1. That means we can apply a point load at this point, number 1. Second condition, we will see again reference geometry, point, different options. Second one is arc center, right? Let's see, select the arc center. Now it is asking at which arc you have to point, make a point. If you select that arc, right, like this one, okay. Now if you select this circle or arc, one point will be generated at the center, second point is generated, okay, click. So second point is there. This is one point where you can apply your required load as a point load, right? Another thing will show reference geometry, point. Now here the condition intersection. If you select this one, at the intersection of two straight lines, one point will be generated. So selecting first line, second line, intersection of these two straight lines is providing that this point, third point is generated. Okay, this is the point 3, right? Another thing you can show, again reference geometry, point. We have an option like this one. At a specific distance away from a straight line, we can produce a point. Select this one. Now let's select any straight line. Suppose this one was selected, right? What it is showing, 15 mm away from this straight line, from here to here 15 mm away, this point is generated. This distance you can vary, 25 mm away, 35 mm away. So these are the different things. At different distance away you can produce a point where we can apply the load. Okay, done. So how many points we have created? 4 points. At these 4 different points we can apply point load. Another one is required, that is you have to apply a pressure on a specific area. So we require a area. This rectangle is created. On this rectangular place or rectangular area we have to apply a pressure, right? We have to select this one. Some split is required. So what to do is external load we are applying pressure. Now it is asking split, right? Split is asking. What it is, first we have to select the sketch. That sketch is required. Next part is it is asking the face. Select this face. Face is selected. Create split. Split is done. So at this area we selected first. At this area split it created. That means we can apply a pressure at this specific area. Okay, done. Now we have to apply these loads, right? Okay. First we'll apply a point load over at this point, right? So external load, force on this point. This point is selected. How much Newton? 1 Newton. We can make this variable, make 1000 Newton, suppose 1000 Newton at this point is required. Now here the direction is very important. Here it is applying as like normal. We have to select direction. Different options are available here. Is normal to perpendicular to, this is perpendicular to that face, right? We click this one, normal to plane number 1. To see this one perfectly, what can you do is, if we click here, it's showing upward direction. If you want to reverse the direction, reverse it. So point load of 1000 Newton. How much Newton we can see? 1 Newton applied. So we can change it. 1000 Newton force is applied on that point. Done. Now let's suppose we want to apply a point load here also. You have to apply the same thing. You want to apply the load at this point, same thing. You have to apply the load here, same thing you have to do. Now we have to apply pressure at this specific area, right? So external load, pressure on specific area. See, it will select this area only, or other part, this part also you can select. You can select here also. this part also, because these are specific areas splitted. We already splitted some specific areas. We can apply pressure here also, or here also. These are the specific areas, these are the specific things, right? Now what cases you have to apply pressure here, right? Done. How much pressure you want? 1 megapascal. Okay, 1 megapascal pressure will apply on this rectangle part. Okay, done. We have applied a point load here and a pressure of 1 megapascal at this point, at this area. We can apply here also, here, so that's not required. We know how to apply. So let's see the analysis right now. Load is applied. Next part is we have to check the mesh and run. So mesh and run is running, and result is being generated. So it is generate result. So you can check yield strength is 2.5 10 to 8. We can check it in different unit by edit definition, change the unit. 1 is stress unit is Newton per megapascal. We change it. Okay, now see, yield strength is 250 megapascal and maximum stress developed equal to 220 megapascal. So it is safe. We can check. Red part is the maximum stress. These are having maximum stresses, right? So we could apply load on different point or specific areas, and we found the stresses generated, right? So thank you so much for watching this video. If you like, please subscribe and share, and if you are having any kind of queries, please write to me. Thank you so much for watching this video. Thank you again. Bye.